Avinash Angadi, working as assistant professor in Department of Civil Engineering, Walchand Institute of Technology, Solapur. Today we will discuss ground improvement technique. Learning outcome: at the end of this session, student will be able to apply suitable ground improvement techniques for construction of footing in difficult soil. What is ground improvement techniques? Okay, so the process in which in situ soils are improved for the support of the foundation of settlement or time in which occurs. Okay, then ground improvement is modification of ground properties to achieve the ground condition for the particular use of the ground. It means ground improvement is modification of the ground properties. Ground properties means your soil properties to index and engineering properties. Okay, that ground improvement is the application of various geotechnical techniques that are used in re-engineer existing soil to improve its engineering characteristics. Engineering characteristics means index and engineering properties. Here some geotechnical failures due to poor strength or increase in pore pressure in the soil mass. So these type of failures are occurred. So this one is Linin Pisa. Due to earthquake condition, this entire building is collapsed. So these are some geotechnical failures due to poor shear strength. Purpose of ground improvement. What is the main purpose of improvement in your soil? Okay, so first one is increase the bearing capacity of weak soil. First main aim of your ground improvement technique is increase the bearing capacity of the weak soil. Weak soil means for example your black cotton soil. You can take a black cotton soil. You need to increase the bearing capacity because your black cotton soil is highly compressible soil. So decrease the amount of settlement or time in which it occurs. If in case increase the bearing capacity, automatically your settlement is decreases. Next, it consider slope. Improve the stability of slope or a vertical cut or a underground opening. Then why ground improvement technique is required? To accelerate the rate of drainage. Okay, so reduce the seepage, then estimate the possibility of liquefaction. So next, methods of soil improvement or ground improvement techniques. Okay, then many are there. Then first one, Vibro-compaction, then Precompression, sand drains, then Vibro flotation, then last one, grouting techniques. Next, we will discuss one by one techniques, ground improvement techniques. First one is Vibro-compaction. Okay, so Vibro-compaction densifies the clean then cohesionless granular soil by means of downhole the vibrator, which is typically suspended from a crane and lowered vertically into the soil under its own weight. Okay, then penetration is usually aided by water jets integrated into the vibrator assembly. Okay, what will happen? We will attach one water jet along with your vibrator. Okay, then after reaching the bottom of the treatment zone, okay, for example, I need to excavate the depth is 1.2 meter. Okay, then after reaching the bottom of the treatment zone, the soil are densified, okay, in lifts as the probe is extracted. During Vibro-compaction, clean sand and backfill is typically added at a ground surface to compensate for the reduction in soil volume, okay, resulting from the densification process. What happened during Vibro-compaction? Some volume of soil mass content is reduced. That's why we will refill the some sand backfill is to maintain the some density of the soil. Okay, the vibratory energy reduces the intergranular forces between the soil particles. Okay, the vibratory energy reduces the intergranular forces between the soil particles. What will happen? Allowing them to move into a denser configuration. Okay, if in case it reduces the intergranular forces between the soil particles, it move into your denser configuration. Your soil is converting into your denser. Okay, then you are typically achieving a relative density of minimum 70 to 85%. Okay, the treated soil have increased the relative density, then your friction angle and stiffness. So this is the vibro-compaction process. This is stage 1, stage 2, stage 3, stage 4. I will explain step by step what will stage 1. In stage 1, the jet at the bottom of the vibro float is turned on and the vibro float is lowered into the ground. This is your vibro float. Okay, and this vibro float or this jet at the bottom of the vibro float and stirred on. Okay, then after reaching your required depth, you need to turn on the vibro float, then lowered into the ground. Second step, the water jet creates a quick condition in the soil which allow the vibrating unit to sink. Okay, here along with this vibro float, we will attach or we will assemble one water jet, because of this entire soil mass is in highly dense in state. Okay, so that's why we will attach the water jet. It creates the in quick condition. Okay, it's quick condition which allow the vibrating unit to sink. In stage 3, here charging of granular material. Okay, we will use some we need to refill the soil sample like your granular material. Okay, first granular material is poured into top of the hole. Here poured into top of the hole, this is your granular material. Okay, and this granular material is poured into the top of the hole. Okay, the water from lower jet is transferred to jet at the top of the vibrating unit. This water carries a granular material. This water carries that water carries a granular material downhole. Okay, downhole. In fourth step, okay, in fourth step, compaction of charging material to desired unit weight. Okay, the vibrating unit is gradually raised. Okay, first you observe here, this is a entire empty borehole. Then second step, we will add some granular materials through your through this vibrating jet. Okay, so after 0.3 meter, okay, for example, your entire borehole is 1 meter. You can take a you can assume this entire borehole is 1 meter depth. Okay, in entire 1 meter depth, we cannot add complete 1 meter depth at one time. Okay, we will add step by step. For example, first we will add some 0.3 meter. Okay, only 0.3 meter we will add the granular material, then again we will compact it properly. Okay, then that vibrating minimum vibrating is 30 seconds at a time. Okay, then again your 0.3 is over, then again next step, next 0.3 meter, then again 0.3 meter. Okay, so goes on up to a ground surface. Okay, and this is the vibro-compaction process. Second technique is pre-compression. Okay, so what do you mean by pre-compression? The pre-compression is deliberate act of compressing the ground under an applied pressure before placing or completing the structure load. For example, this is your main ground surface. Okay, and above this ground surface I am planning to construct one superstructure here. Okay, then before construction of superstructure, before construction of superstructure, we will predetermine means first we will apply some surcharge load. Okay, that surcharge load, and that surcharge load is call it as a surcharge load or preload, that we can call it as precompression. What is the main principle? Okay, when you apply the preloading, okay, this surcharge load, when you apply the surcharge load or preloading on soil mass, what will happen? It increases the pore water pressure. Okay, so in the soil mass, within the soil mass, and as a consolidation process occurs. Okay, an increase in the white consolidation process it occurs, an increase in the effective stress takes place in the soil accompanied by surface settlement. Okay, then next, the preloading material placed over the ground to be improved in the amounts sufficient to produce a stresses in the soil equal to the anticipated from the final structure. Okay, and this preload we will equal to this your final structure load. Okay, then the time required for settlement of full consolidation varies directly as the squares of the layer thickness and inversely as the permeability. Okay, your settlement is depend on your consolidation process. Okay, and this consolidation is directly as the square of the layer, it means your thickness of layer thickness, and inversely as the permeability of the soil sample. Thus, preloading alone can be sufficient only when the thickness of layer is less. For example, your depth of the foundation is more than 1.2 meter or more than 10 meter. It's not possible to apply the preloading technique here. Okay, the only possible when your soil layer thickness is very less. Very less means your soil layer thickness, you can take only 0.5 meter or 1.2 meter. Okay, in that time it possible to apply the preloading technique here. Okay, and more construction time is allowed in the development of the project. Otherwise, surcharge fill may be successfully used. So, using conventional theories of consolidation, okay, by consolidation theories, the amount of surcharge fill required and the loading period can be estimated. Okay, so we can estimate the loading period, that surcharge load. Okay, by using this consolidation theory, we can calculate the surcharge fill. Surcharge fill means your thickness of layer. Okay, thickness of layer and loading period. For example, loading period is your surcharge loading period means your time period. 1 minute, 2 minutes, 1 hour, 2 hours. Okay, because your consolidation is time dependent. Type of settlement. Okay, the effect of pre-compression on each phase of the settlement of finished structure load are beneficial. Here one graph is the typical graph. This axis is your time and this axis is your load, then below is settlement. Okay, so when you apply surcharge load, okay, then when you apply surcharge load, for example, if you apply 10 kilonewton, okay, some settlement is occurred. Okay, we can call it as that is your immediate settlement. Okay, that immediate settlement is get occurred. Okay, then goes on increasing your loading condition. Okay, 10 kilonewton to 20 kilonewton, 20 kilonewton to 30 kilonewton. So your load is increasing with your time. So what will happen? Your settlement is goes on increases here. Okay, in first step you can observe this second graph, log time versus your settlement. Okay, then first step is occurred in immediate settlement. Okay, then second step, if you increase the loading condition, okay, so what will happen? Your primary or primary consolidation settlement is occurred in second condition. What do you mean by primary consolidation settlement? If there any water is expelled out from the entire soil mass. Okay, then third step is secondary settlement. If in case after occurring of primary consolidation, if there any some water content is present still in soil mass, in that time your secondary settlement is occurred. Okay, here secondary settlement means if in case any excess pore pressure, okay, remaining pore pressure or excess pore pressure or any water content is remaining in is get expelled out. Okay, delta U is 0. And last one is creep. Okay, and this is all about type of settlement. Okay, for example, a type of settlement in settlement phases, I already mentioned that immediate settlement, primary consolidation, or secondary consolidation, or in creep. In immediate settlement, it minimizes the amount of the soil sample. For example, you can assume your depth of the soil sample is 1 meter. Okay, when you apply the precompression or surcharge load, it minimizes the some volume of the soil sample. Okay, then second step, primary consolidation. Primary consolidation, it reduces the amount. Amount means it get expelled out water content or any it get expelled out water. Okay, in this stage. Okay, in last third stage, secondary consolidation, it reduces the rate. Okay, and this is what happened in type of settlement in this entire graph. So these are the references. I'm preparing the PPTs. Thank you.